Introduction to decimals. When you have numbers to the right of the decimal point, these numbers are small. They're less than 1. And depending on what spot the digit is in, gives us the name of that particular location in the decimal. So, the first digit to the right of the decimal is in the tenths place. Next is hundredths, thousandths, 10,000ths, 100,000ths, millionths, and so on. And you could keep on going. So we're going to look at converting between the digits and the words. If we want to write the following out in words, we'll look at the first one, 1.004. So the whole number part is 1. So we'll write the word 1. And then you write the word and. Now we have to figure out what place the 4 is in. So to the right of the decimal, it first goes tenths, then hundredths, then thousandths. So the 4 is in the thousandths place. So we write 1 and 4 thousandths. Looking at the next one, there is no whole number. And so you go to all the way to the end to determine if you're going to call it tenths, hundredths, thousandths, whatever. So looking to the right of the decimal, the first digit is tenths, then hundredths, and then thousandths. So at the very end is thousandths. That's what we'll write for our answer. And we've got the 4 and the 5, just put them together. So the answer is 45 thousandths. The third example, 26.2. So our whole number is 26. Then the word and. To the right of the decimal, the first digit is in the tenths place. So it'll be 26 and 2 tenths. Now let's go the other way around. We're given words and we're supposed to write the digits. Write in standard form. 407 and 3 hundredths. So 407. And then where we see the word and, we'll put the decimal. 3 hundredths. Hundredths is the second place after the decimal. So we don't have any tenths. And there's our 3 hundredths. Now often when we're dealing with decimals, we have to round. And you'll always be told what place to round to, the tenths, the hundredths, the thousandths, and so on. So once you find the location of the digit you're supposed to be rounding to, the tenths, hundredths, thousandths, whatever, you look one digit to the right. If that number is 5 or bigger, you bump up the number. If it's not, you leave it alone. So for example, if I'm to round 6.249 to the tenths place, that's where the 2 is, I look to the first digit to the right of the 2. And we have to ask ourselves, is that number 5 or bigger? No, it is not. So I don't change the 2. The answer is 6.2. For the second example, 18.40937, we are being asked to round that to the hundredths place. That's the second place after the decimal where the 0 is. So I look to the right, I look at the 9. 9 is bigger than 5, 5 or bigger, so that means I need to bump the 0 up to a 1. Third example, 72.4983, rounded to the hundredths place. Again, that's the second number after the decimal. That's this 9. I look to the right and ask, is that 5 or bigger? Yes, it is. It's an 8. That's bigger. So the 9 needs to bump up, but what does 9 bump up to? 10. How are we going to do that? We can't fit an extra digit in there. So look at the 0.49 as a whole. Think of that as 49. And so we'll round it up to 50. 72.50. And now it's rounded to the hundredths place. One more rounding problem. 47.3192 rounded to the nearest whole number. Whole numbers are to the left of the decimal, which would be this 7. I look to the digit to the right. Is it 5 or greater? No, it is not. It's a 3. So the 47 just stays. And then it's rounded to the nearest whole number. Let's look at comparing two decimals to determine which one is greater. So we're told to place one of these two symbols in between. The first one is a less than symbol, and it looks a little bit like an L that's tipped over, L for less than. And the second one is a greater than. So we want to put the appropriate symbol, less than or greater than. I'm looking at the first example here, 0.278 compared to 0.203. The number of digits after the decimal are the same, so we can just compare 278 to 203. And 278 is greater than 203. The next example, though, the number of digits after the decimal are not the same, and that makes it a little bit harder to compare. But we can change that just by adding zeros until they have the same number of digits. So the first number has 3 after the decimal, 0.037, and I can make the second one also have 3 digits after the decimal if I just add a 0. You can add as many zeros as you want to on the end of a decimal. Now I'm comparing 37 to 130. And so 37 is less than 130. Then looking at our final example, comparing, the one on the left has 3 digits after the decimal. The one on the right has 5. So I can add 2 more zeros to the first one, and now it has the same number of digits as the second one. So I'm comparing 3,100 to 987. 3,100 is greater than 987.